Good morning, students. Welcome to PPS online class. In today's session, we will discuss about the standard input, standard output, and standard error thing. Uh, the way how we give input to our programs through standard input, and the way how we take output from our program, that is through standard output. And there is another thing which is similar to your standard out, that is standard error. So all these things we will discuss in today's session with practical demonstration, and it is a simple topic. Hope it will not take much time. First of all, we need to know what is this standard in, stdin, and what is this standard out, stdout, and what is this standard error, stderr. Okay, so they are streams. Basically, they are streams. So about these streams, more in detail, you will understand when we go for CPP, C++ programming. So stream is nothing but the way how we define stream in our real time. Stream is nothing but the flow, the way how the water will flow in a river. We call it as the water stream. Okay, so here when we say stream in our computing, stream is nothing but the flow of data. So from where the data is originating and to where the data is going. Okay, so in that flow, the way how the data will flow, we call it as a stream. Okay, so all these whatever we said, standard input, standard output, and standard error, they are all streams. Okay, because they are either the origin of data or either the consumers of data, likewise. Okay, so because of that reason only we call them as streams. Okay, the terminal points, either the data originators or either the data consumers. Okay, because of that reason only we are calling them as stream, because after origin the data will not stand at one location. Obviously it will flow towards some other location, isn't it? As you can see, the standard input, it is the originator of data. Okay, here the data will be generated, and obviously after generating it will flow towards our program variables, isn't it? Because there only we are going to store the data. So the data will flow from the standard input towards our program variables. So in that point, there is a data flow. So because of that reason only we are calling them as stream. Same thing for standard output and standard error. Standard output will take the data to display, and standard error is also similar to that one. It will also take the data to display, take the information to display. Okay, so in today's session we will discuss about all these three: standard input, standard output, and standard error in C language. Okay, so as you can see, the programming, it requires input and output activities. Obviously, we said before, processing the data through our application, through our program, the data has to be read into, and the data has to be processed, and after that the data has to be output, isn't it? And C language uses standard in, standard out, and standard error streams to effectively manage these processes. I mean, to effectively manage input output activities. Okay, so here we thoroughly discuss how to what are these streams, and what is the purpose of these streams, and what will be the syntax and usage of these three streams: standard input, standard output, and standard error. Okay, so standard streams in C, there are three: standard in, standard out, and standard error. Make input and output operations easier. Okay, so unknowingly, see, without knowing their purpose, without knowing their syntax, so far we dealt with these standard input. Whenever you read the input using keyboard, unknowingly you have used standard input, and whenever you send the output to the console, unknowingly you have used this standard out as well. So in today's session I will explain how you have interacted with these standard input and standard output. Okay. And these are the components, your standard input, standard output, and standard error. These are components available in standard input output library file only. So to use them, we no need to import any additional library into our program. So what is standard in? What is standard in? Standard in stands for stdin. Standard in stands for standard input. Okay. It represent the input stream, standard input stream, flow of data, okay, which is normally connected to the keyboard. So whenever I said earlier also I explained this thing in your classroom. So whenever you see standard input thing, immediately you have to understand it like a keyboard only. Okay, so keyboard pointer, so more or less you can understand this stdin, whatever we are seeing, stdin, you understand this as a reference, as a pointer to your keyboard. Okay, to your keyboard. So in order to interact with the keyboard, we somehow need this stdin. It is readily available. We no need to create this constant, or we no need to create this keyword. It is readily available inside your stdlib.h, standard io.h. Okay, so it enables programs to read user entered data while they are running. So while your program is under execution, through this reference, through this pointer only, we are going to read the data, user entered data from the keyboard, from the standard input device into our program application. Okay, line buffering is the default setting for standard input. Okay, what does it mean? In the sense, every line, I mean, at what time it will stop the reading process? In the sense, your line buffering, a new line character will act like a terminating point for that stream. Whenever you are reading some data, after inputting the data, what we do, we push the enter key, isn't it? We pushes the enter key. So when you push the enter key, what this push will input, in the sense, a new line character it will input into your input stream. Okay, into your stream of data. Whatever data will flow as an input from the keyboard to your application. In that application, if you hit the enter key, it will input the new line character. So this new line character will act like a terminating point. Okay, so hopefully it is clear. Same thing, standard output. What is standard out? Standard out stands for standard output. Okay, it represents the standard output stream. So what is the attached? I mean, attached device or attached thing for this standard output stream, in the sense, your console or terminal, whatever black screen we see when we execute our program, that will act like a console or terminal for our application. So that will be the referring point. Okay, through this standard out pointer, that will be the referring point in our program. Okay, so standard out will act as a pointer, stdout, standard out will act like a pointer to this terminal or console. So whenever you refer to this standard out pointer in your application, indirectly you are referring to the console or terminal. Okay, so it makes it possible for programs to show the user information or results. So output, after generating the output, that output has to be displayed on the console or the terminal. So through standard output only, we are going to display, or we are going to show that output to the end user. Okay, it is also line buffered. Okay, it is also terminated. Your standard output, how it is going to terminate? Through line buffering only, it is going to terminate. Okay, then we have this standard error stream. It stands for standard error. stderr stands for standard error. Okay, so it is represented by the standard error stream. It is more or less similar to your output stream only. The way how output is displayed on the console or terminal, your error message, standard error, is it is usually used to send the error message to your console or terminal. So it is more or less similar to your output stream only. So here also your stderr, whenever you use this pointer in your application, in your program, it is also referring to the terminal or console only. Okay, so it is another type of output stream. We can call it as a second type of output stream typically used by programs to output error messages or diagnostics. Any kind of diagnostic information or any kind of error messages you want to push as an output from your application, then you have to use this standard error, and it is a kind of output stream only. Okay, there is a difference between standard error and standard output. That is the reason why we have two different streams but not a single. Okay, so that difference, it is not under your discussion, so we'll be not discussing. Just remember this standard error as another type of output stream which is used to send the error messages, or which is used to send the diagnostic information from your application. Okay, and where that diagnostic information or where that error messages are going to be displayed, in the sense on the output screen itself, on the console or terminal itself, because standard error, it is also referring to that same type of terminal devices. Okay, hopefully it is clear. It is a stream, your standard error stream, it is a stream independent of your standard output and can be redirected separately. Okay, that's the reason we have a separate pointer for it, separate reference for it, in order to send the messages to the output console, as it is independent of output, standard output. We no need to depend on standard out in order to send the error messages onto the output screen. Okay, do remember in that way only. And whatever a concept they will ask onto this topic in your program, you have to give only this much explanation, not beyond it. You have to give only this much explanation, which is more than enough. Okay, so we'll understand the syntax of using this standard in, standard out, and standard error through programming examples. Okay, so as I said, your standard in, stdin, it is used to read the input from the what we call input device. Okay, we have a standard input device, that is keyboard. So from that keyboard to read the input, we use this stdin. Okay, the scanf function, so far what we used to read the input from the keyboard, the scanf function. The scanf function, it is associated with your standard input, what we call the pointer. Okay, standard input thing, it is associated with the standard input, your scanf function. So whenever you are reading some content, some data from the keyboard, then you are using this scanf, and scanf by default it is associated with the standard input device. So standard input output function, your scanf, it is by default associated with the standard input. That's the reason whenever we use scanf, we don't give any reference to this standard input thing. Okay, we don't give any reference to this standard input in our scanf. As you can see the syntax, scanf of directly format specifiers. What are format specifiers? Our conversion codes, percentile S, percentile D, percentile F, respective to the type of data which we are reading, we give this format specifiers. And nowhere we are referring this standard in into the syntax of scanf. The reason, because it is by default associated with the standard input pointer. Okay, so and then we give the addresses where we want to store that data. Okay, and percent variable, whatever I am suggesting here, it is nothing but the what we call the and percent variable. It is nothing but the address of a variable where the data what we are reading is going to be stored. Okay, hopefully this is clear. So scanf by default it will be associated with the standard input stream. Okay, and then we have file specific functions like your fscanf. So generally fscanf we use to read the data from a particular file, isn't it? And in the syntax of fscanf, the first parameter is going to be the pointer to that file, isn't it? Pointer to that file. But if you want to read the data using fscanf from the keyboard, fscanf generally it is used to read the data from the File, because it is a file specific function we said, isn't it? File specific function. So now you can make this file specific function as a general purpose function, just if you add the uh, what we call pointer of your input stream. What is the pointer to the input stream? stdin. So this is the pointer to your input stream, pointer to input stream. Okay. Suppose if you have a file with the name say sample.txt, then I'm opening that file. How we will open? File star fptr is equals to fopen. Assume that this file is existing, sample.txt comma, I'm opening this because I'm reading the data only, so I'm opening it in read mode. So now this file will be opened and the pointer will be stored in fptr. So if I put fptr over here, then your fscanf function will read the data from fptr file, isn't it? Will read the data from fptr file. But if I put stdin in place of fptr, if I put stdin is a reference to what? Stdin is a reference to input stream. That is nothing but your keyboard. Okay, stdin is a reference to keyboard. So from where fscanf function will read the data? In case if you put stdin here, now it will read the data from the keyboard. Okay, this is something like scanf only. fscanf of stdin, if you put, it is same like your scanf, reading the data from keyboard. Okay, this is how you can make your file specific function as a general purpose function, so that you can read the data both from a file as well as from a standard input stream. Hopefully you understood. Okay. Next thing, your standard output. For writing the output, we use this standard output stream. And what function is by default associated with stdout, in the sense your printf function. Okay, your printf function, it is by default associated with your standard output. Here they have given the printf function is used to display output to the user through standard out. Okay, whatever data you want to display, you want to put as output onto the standard output, through printf only you have to give. Or we can say whatever data you give through this printout, that will be directly redirected to a standard output only, your console or terminal only. Okay, so how you can make your file specific function so as to display the output on the file specific function fprintf, where it will write the data to a file, it will write, isn't it? To a file, it generally writes the data. But if you want to write the data onto the standard output using fprintf, just pass the file pointer as stdout, standard out. So now where it will print the given data? Onto the standard output. It will not write that data to a specific file, rather it will write that data to a standard output device. And in our consideration, in our C programming, what is the standard output? Your console only. So it will write the data onto the console. Don't worry, we will write a program by using both printf as well as scanf, and fprintf, fscanf, by giving the standard out as the output reference, output stream reference, and standard in as the input stream reference. There you will understand. Okay, then the error, standard error, it is also same like your printf. Standard error, it is directly associated with printf. To display the error messages or diagnostic information from your application, generally we use this printf message only. So your standard error stream is also associated with printf only. Okay, so if you want to make your file specific function as to display the diagnostic information, just pass the standard error reference over there. Okay, standard error stream reference over there, so as to see the diagnostic information on the output screen. So it is both your standard out, standard error, both acts similar. Okay, both will have the same behavior from your program. Okay, now a programming demonstration. A simple program I have written over here. So just what I'll do is I'll read the two variables and I perform the sum and I will print the result. Okay, and I will print the result. Just now I will not use the standard input output functions like printf, scanf. Rather, I will use general purpose functions like your fprintf, fscanf. Fprintf, in place of file pointer, I will use the reference. I will use the pointer to my output stream. And in same thing for fscanf, in place of file to read the data, in place of file pointer to read the data from a file, now I will give the standard input reference, keyboard pointer, that is stdin, in my program. Okay, so quickly I will demonstrate this onto the dev cpp. So I'll create my, okay, stream demo. I'm giving my program name as streams demo, streams demo.c. Now I will write my code. Sorry. Okay. No need of any further what we call header files inclusion, as all my pointers, standard in, standard out, and standard error, they are part of stdio, standard input output header file only. So I will create three variable, num1, num2 to hold the numbers, and sum to hold the result. Okay, now I need to read the first what we call first number value from the keyboard I want to read. So how I will write generally, first we need to give the message, isn't it? For giving the message, we used to use this thing, printf message. Printf, enter num1 value, ఇలా ఇచ్చేవాళ్ళం. num1 value input చేయమని ఇలా ఇచ్చేవాళ్ళం. So now what we have to do, in place of num1 value, we simply enter num1 value. This will be acted like a string, isn't it? This will be acted like a string. So what I have to do, I don't have to use the standard output function, that is printf. Rather, I will use the fprintf function. Fprintf of, first thing what we have to give, we need to give the file pointer. So if you are writing the data to a file, in that case you will give the file pointer. But now I'm writing the data to the standard output on the console. So I need to give the reference to that console. So what is the reference to that console? stdout. Standard output will be the reference. And what message we want to write? Enter num1 value. This is same like the printf which I have written in the comments. Comments lo edaithe printf rashano, it is exactly same to that. Okay, this general purpose function, it is exactly same to that. Okay, because why I'm not giving standard out over here, in the sense because printf is directly by default associated with standard out. That's why I'm not using any reference over here. But fprintf, as it is general purpose, it can write to a file or it can write to the standard output as well. When it is writing to a file, give the file pointer. Okay, when it is writing to the standard output, give the standard output pointer. That is the difference. Okay, now for reading. Okay, for reading the value, how we write the scanf, the format specifier %d and the variable address. So num1, this is how we have to give in case the standard input function. But instead of standard input, I will use the general purpose input, that is fscanf. It can read from a file as well as from a standard input. Now I want to read from the standard input. So standard in, okay, then format specifier %d, comma, address, variable address, and %num1. Okay, this is how we read the first variable. Now read the second variable value. Printf is the default for printing the message. Enter num2 value, but I want to go with the general purpose thing, that is through fprintf. Okay, my file pointer is going to be stdout, comma, enter num2 value. Enter num2 value. Go to the end, put the semicolon, and now what I have to read the variable value. Scanf is the standard thing. So scanf %d, comma, ampersand num2. This is how it should be. It should supposed to be with the standard input function, but I'm going with a general thing. So scanf, fscanf of stdin, comma, format specifier percentile d, comma, variable address and percent num 2. Okay, so we read the two values, num1 value, num2 value. Now calculate the sum is equals to num1 plus num2. Now I want to display the output. So again, in I don't want to use printf. So if you are using printf, how the result will be, how the output will be, printf sum is equals to percentile d, comma, sum, like this it has to be. But through fprintf, how it will be, fprintf of, where we are sending this to the standard output we are sending, and what string we are sending, sum is equals to percentile d we are sending, and what value percentile d has to be replaced with some value percentile d has to be replaced with. That's it. Then return 0. That's it. Save the program, compile the program. Compilation, as you can see, it is successful, and run the program, and it is asking me to input the value of num1, and from where we are printing, from fprintf we are printing. As you can see, this I kept in comments, so it is not coming from here, it is coming from here. And as I have given the reference of standard output, so this is the standard output screen. So on to this standard output screen, this message we are seeing, enter num1 value. So if I give 25 as input, and after 25 I need to hit the enter key so as to give new line character in my input stream. So hit the enter key, and from where it read this 25, using fscanf it read the 25 and stored into num1. Now my num1 is 25 and num2 I am giving 33. Okay, and I'm getting the sum as 58, as you can see from here. From here I got the second message. From here I read the num2 value. Here I calculated the sum, and from here I am outputting the sum value. Sum is equals to 58 I am getting on the output screen. So this is how we can use your standard input, standard output stream pointers in your program so as to read the data from the standard input, and so as to write the data to the standard output. Hopefully this program is clear. This is what we have the concept under this standard input, standard output, and standard error. Standard error is also same thing, just to write the error messages or diagnostic information onto the output screen. We make use of this standard error. Hopefully the concepts are clear. Okay, thank you very much, students.